So you've learned how to find sums by hand. You've learned how to use the arithmetic sum formula. There's two final formulas you need to know, and it deals with geometric series. The first formula is when you're finding the sum of an finite geometric series, which means it ends. So you have a certain number of terms, 11, 12, 13 terms. You are not seeing that the series goes on forever and ever and ever. The second formula you're going to learn is when it does go on forever and ever and ever. And you may say, well, how would that have a sum if you keep adding these numbers together and the series keeps going on? Well, it depends on what's happening with the numbers. We've talked about this idea of converging and diverging, and that's something you have to consider when you're looking at an infinite geometric series. So let's start with the finite ones. You're going to see this formula right here. So if I said find the sum of the first 11 terms, in order to use this formula, it needs to be geometric. So I need to make sure that I am multiplying by the same number each time. Now, if you don't see the pattern right away, then remember you can always take the second term and divide it by the first, and you can get that pattern and check to see if it works for all terms. So notice I'm getting this negative 1/2, which again, some of you guys could have just looked at this and said, oh yeah, that is the pattern. So note the common ratio here is negative 1/2. Now, once you get that ratio, if you want to find the sum of 11 terms, we're going to do S sub 11. Notice that for this formula, you need to know the first term, which in this case is super easy because it was given to us. And then in the parentheses, we're going to do 1 minus the common ratio, all to the nth power, which in this case was 11, over 1 minus the common ratio. Now, a lot of people find this formula to be easier. However, the issue with this formula is the mistakes that I see simplifying it. Whatever you do, do not make this a giant plus sign. Remember the order of operations, and remember that you have to do E, exponents, before you can subtract S. Now, in the denominator, that's okay. You can do 1 plus 1/2 and get 1.5 down here, but you cannot do that up on the top. So you need to make sure you have your calculator for this formula, because trust me, it is very rare you can do any of these problems without the use of a calculator for the finite series. So what we're going to do in our calculator is I always suggest finding the bottom number first, which for this one was easy, but then we're going to find the numerator value second. So you're going to type in 1 minus parentheses, negative 1 divided by 2, and then we're going to raise that to the 11th power. Hit enter. Whatever answer you get, divide it by 1.5, and then always as your last step, multiply by the 6, and we're getting approximately 4.002 as the sum of the first 11 terms. Now you may say, that didn't seem that big, but remember that this is an alternating series. So when we add the terms together, sometimes we're adding a negative, sometimes we're adding a positive. Not to mention the ratio, negative 1/2, these numbers are getting smaller and smaller and smaller and smaller, so you're going to see it does not grow as fast when we add the terms together. Now, you're not going to see the same thing with the next problem. With the next problem, it said find the sum of the series, but notice with this one, we have much larger values. So first thing we need to do is check to see if it's geometric. Notice that I am multiplying by 3 for each term, which means I have a common ratio of 3. Now, when I set this up, the problem here is that I don't know the number of terms this has. So going back to what you've had to do in previous notes, we're going to have to figure out what term number this is. So what I'm going to do is I'm going to set up my formula. If you guys remember, a sub n equals the first term, 5, times the common ratio, 3, to the n minus 1th power. Now, I want to find what term number 98,415 is. So I'm going to fill that in for the last term, and then I am going to solve for n. Getting a little excited because this is an exponential function. You just learned about this, 98,415. We could divide by the 5 in the front, and then from there, we can write this in log form. Remember, I've also talked about how, you can do exponential form you can do guess and check as well. Or, take the log of both sides. I'm going to rewrite this as log base 3 of 19,680. How many times am I going to do that? 83 equals n minus 1. So in your calculator, you can either go to math and go to that log base button, or you could do the change of base formula. So there's log base if you do have it, and make that a 3. Make this 19,683. And then you get a 9, but then don't forget to add the 1 on the other side. So I get that this is n equal to 10, or my 10th term. So that means that for this specific series, I am adding 10 terms together. So going to, let's make this work in the order that I'm doing it. Lasso that. We are going to be finding the sum of 10 terms, and we are going to fill in the first term, and then 1 minus that common ratio of 3, all to the nth power, over 1 minus that common ratio of 3. So again, using your calculator, find the denominator value first. That's negative 2. Then find the numerator value. This is going to be big, but negative because 3 to the 10th power is going to be a very large negative number. Then we can divide that by negative 2. And then we can multiply that by 5. And we get 147,620. The number of times my kids say mommy throughout the day. Say mommy. Mommy, mommy, mommy. All right, so moving on to the next one. Now we're seeing sigmas. Remember, with sigmas, you need to make sure you look at the formula to the right. This is not a linear equation like I last taught you. But if this is an exponential equation, you can use the geometric formulas. So with that being said, let's use that formula. First thing is, how many terms does this have? Remember, we have to take the top number minus the bottom, but then add 1 to this. This is a total of 9 terms. Now, we need to find the sum of 9 terms, but the first thing we need to know is the first term of this. Remember, the first term is when we sub in the bottom number. If you sub in the bottom number, because we have the n minus 1, you see that exponent becomes 0, negative 2 to the 0 power is 1. We just get that first value of 5. Now, in the parentheses, we're going to do 1 minus the common ratio, and lucky for us, this is very easy to find. It's just going to be that negative 2, and then we're going to raise it to the 9th power, all over 1 minus the negative 2. So again, denominator value first. We can do 1 minus negative 2. That becomes a 3 down there. But then we have to use our calculator to find the numerator value. So we can do 1 minus the negative 2 raised to the 9th power. We can divide that by 3. And then we can multiply that by 5. So we're getting 855. Same thing with the next one. The next one, be careful though. This is just a big issue, is really just finding the number of terms with these. Some people would just say, oh, this is 20 terms, but that's not true. When you take the top number minus the bottom and then add 1 to that, this is actually 21 terms. And if you're like not convinced on that, just make the bottom number 0 and the top number 1. That's really 2 terms, subbing in a 0 and a 1. So you don't just subtract the numbers. Be careful with that. So we're going to be finding the sum of 21 terms. So we're going to take the first term here. Now remember, sub in the bottom number to find the first term. And because there is no n minus 1, but the bottom number is 0, we get that 3/2 to the 0 power, which is 1, times the 3 in the front. We do get a first term of 3. In the parentheses, we're going to do 1 minus the common ratio. Common ratio is what's being raised to the nth power. So we're going to get that 3/2 all to the 21st power over 1 minus 3/2. I don't know, lots of parentheses there. It's a parenthesis party. If you do 1 minus 3/2, 3/2 is 1.5. So just make sure you get a negative 0.5 down there. And then we can find what's in the numerator. Raised to the 21st power. And then we can divide that by the negative 0.5. And then multiply that by the 3. And we get approximately 29,921.31. Let's bump that up to a 1. And then that is your sum. Moving on to the final set of problems. Let's go with that. The final set of problems involve infinite geometric series. Now, what do I mean by that? If I ask you on number 16 to add an infinite number of terms, you have to be careful with this. If the terms keep getting larger and larger and larger, there would be no sum. If I keep doubling things, and I do this for all of infinity, like for all time, the numbers just get too big. They don't approach a value. But if your series converges and the numbers are getting smaller and smaller, you are able to find the sum, because remember, these approach a value when they converge. So technically, every time you add a new term, it's like adding that same quantity, this quantity that's getting smaller and smaller and smaller and smaller. So when you are using this formula, this only works if your ratio is less than 1. Now, that means multiplying by a half, multiplying by a third, multiplying by a fourth. Obviously, absolute value, so multiplying by -1/2 is still going to have that same effect, making the numbers get smaller and smaller and smaller. Now, if you look at this formula, it's very simple, but think about why. If your ratio is less than 1, let me go back up to here. If I were to take like 1/2 and raise it to the 100th power, think about how small this gets. Technically, it starts becoming very close to 0, and that's why on the top you just have a 1 left over. And that's why down here you're going to see in the formula it just says a sub 1, whatever that first term is, because ultimately it just becomes this a sub 1 times 1 in the top, and that's where you're getting just a sub 1 in the top of the formula, is because this r to the n technically goes to 0. So let's use the formula. First thing we need to do is find what that ratio is. If you don't see it right away, take that second term and divide it by the first. 6 divided by 9, and then let's reduce that to 2/3. And then just make sure it works for all terms. I always just take a moment, look. We're all good. So to find the sum of infinitely many terms, you are going to write the first term on top and then 1 minus that common ratio. Now, these are so easy. It doesn't get more complicated than this. 1 minus 2/3 is a third. And then remember, dividing by a third is like multiplying by the reciprocal. We get a sum of 27, and that's it. So I know it is hard to believe, but think about how if these numbers keep getting smaller and smaller, the biggest amount you're getting is from these first few terms. And then after that, it just starts leveling off and getting closer and closer to 0 that we're adding each time. Going on to the next question, 17. Again, check to see if the common ratio is a number that's less than 1. So I can take a2 and I could divide it by a1. So in this situation, I'm going to do 1 over 32, and I'm going to divide that by 1 over 64. Remember, dividing is the same thing as multiplying by the reciprocal. And notice by doing this, I'm getting 2 as my common ratio. These, surprisingly, are actually getting larger and larger and larger, because if you think about it, you keep multiplying by 2, what we're seeing is that the bottom number is getting smaller, but remember, that makes the whole quantity larger. When you divide by something that is, in this case, smaller, it's going to make the actual amount a little bit larger. So as a result, this has a common ratio of 2, and that ratio is not less than 1. So this right here does not converge. It's actually getting larger and larger and larger. This diverges. Therefore, there is no infinite sum. Could I find a sum of 10 terms? Sure, but that's not what they asked us to do. They wanted us to find the sum of this series that continues to get larger and larger and larger, and because it diverges, there will be no value there for all the terms that keep going with this. Moving on to the next problem, we have some sigmas. So looking at this one, how do I know when I'm going to use this formula when it involves sigmas? Well, first thing, dead giveaway, infinity on the top. Second thing is that we see an exponential function. Now, if the infinity wasn't on top, we would use the other formula as long as this was exponential. So how am I going to do this? You need to check before you even do anything with this one. You've got to check that ratio. This ratio here equals 3/2. And notice that 3/2 is greater than 1. So because of that, we cannot find this. This is actually going to be diverging. And so we can't find the infinite sum. I like to call it the infinite sum because this is an infinite series, but technically we just can't find the sum, but I just like to call it infinite because that's the type of problem that we're dealing with right now is the infinite ones. So that's it. And then for the final one in here, you will see that this one, we are okay. Yes, it is negative, but it doesn't matter. If you keep multiplying by -1/2, you're going to see that this is an alternating series, but think about how the numbers, even if we were at, let's just go -8, and then we go to +4, then we go to -2, then we go to +1, you're seeing that these numbers are getting smaller and smaller, and they are approaching 0. So just something to keep in mind. So if we want to find the sum of infinitely many terms on this one, we're able to do it because our R value is less than 1, put absolute value there just so that doesn't get misleading. So what we need to do is find our first term. Well, to find the first term, sub in the bottom number. If I sub in the bottom number, 1 minus 1, 0, anything raised to the 0 power is 1. Then I need to do 1 minus the common ratio, which in this case is -1/2. So if I make this a plus sign down here, I get 1 plus 1/2. I get 1.5. If you'd rather, you could think of that as 3/2, because then when I do 1 divided by 3/2, it's the same thing as 1 times 2/3. I get a sum here of 2/3. Now you may say, why is that so small? That doesn't make sense. If the first term is 1, how can my sum be smaller than that? Well, remember, we're alternating with positives, negatives, positive, negatives. So my next term, my first term for this is 1, but keep in mind my next term for this would be -1/2. So you're going to see that that takes me just with the first two terms to a sum of 0.5. But then my next term is going to be +1/4. So you're seeing that it will obviously approach this value as time goes on. These terms get closer and closer to 0, and that's why the sum does not get large because these don't start out that big. So that's